Welcome back everybody. Dr. Tom McNamara here again for our course in trigonometry. In this video I'd like to talk about two key ideas, the reciprocal identities and the ratio identities. So in this part of the course we're going to start to explore the algebraic relationships between the trig functions. Now as our starting point, of course, we need to know the definitions of our trig functions. So just for practice, cosine theta, sine theta, tangent theta, x over r, y over r, y over x for tangent. And then we got secant theta, r over x, cosecant theta, r over y, and cotangent theta, x over y. Okay, you'll remember that we are defining the trig functions in terms of an angle in standard position. X and y are a point on the terminal side, and r is the distance from the origin of our angle in standard position. Okay, now, these reciprocal identities I've actually been using a lot when we've worked out the values of the trig functions. I just haven't really explicitly said it. Well, the way I've usually said it is, okay, if you know cosine, then you get secant for free. Just flip it over. Well, the formal name for that is the reciprocal identity. So in other words, secant theta is the reciprocal of cosine. Similarly, cosecant theta is the reciprocal of sine theta, and cotangent theta is the reciprocal of tangent. Okay, so if we know secant, we can, well, if we know cosine, we can figure out secant, but it also goes the other way. If we know secant, we can figure out cosine, because if you take the reciprocal twice, you're kind of back where you started. Okay, let me do a couple of examples here. So this first example, let's say if sine theta equals negative 2/3, find cosecant theta. Okay, well, according to the reciprocal identities, cosecant theta is the reciprocal of sine theta, and the reciprocal of negative 2/3 is negative 3/2. Okay, I'm sure you remember that idea from your algebra course. You want to take the reciprocal of a fraction. It's the multiplicative inverse. You have to swap the numerator and the denominator. Okay. How about this one? Let's go the other way. Let's do this. If secant theta equals 7/3, find cosine theta. Okay, now this is kind of an important idea. This is not simply a formula saying if I give you cosine, then you can find secant. This is a relationship between the two functions, saying if I know either of them, I can figure out the other one. Okay, so secant theta equals 1/cosine. That's equivalent to saying cosine theta equals 1/secant theta. Okay, the relationship of being reciprocals is a symmetric relationship. So if I take the reciprocal of secant, which would be 3/7, I would get cosine. Okay, so very easy idea to apply. Like I mentioned, I had been using this idea without really saying what it was back in the previous couple videos. Now, the other key idea that I put on the board is a bit less obvious. It's called the ratio identities. So, you'll recall, of course, our definitions. I'm repeating these a lot. That probably means they're important. Okay, so let's look at these first three for right now. Cosine theta equals x over r, sine theta equals y over r, tan theta equals x over y. Something I want to note here. If I take sine theta over cosine theta, well, let's go from our definitions here. Sine theta is y over r, cosine theta x over r. All right, let's think a second. We got this fraction divided by this fraction. You remember from your algebra, how do you divide by a fraction? Well, you multiply by the reciprocal. So y over r divided by this would be equal to y over r multiplied by the reciprocal. So the factors of r cancel each other out. You're left with y over x. And look right here. That's equal to tan theta. Okay, we could play a similar game with cotangent. Okay, so the reciprocal identities. The reciprocal identities are the very straightforward ones that we were using the last couple of videos. The ratio identities are these right here. Tan theta equals sine theta over cosine theta. We could do a very similar derivation to help us understand why cotangent theta is equal to cosine theta over sine theta. In fact, it also follows from one of the reciprocal identities that we had on the board a second ago. So, in a certain sense, the sine function and the cosine function are like the two most fundamental trig functions, because you can get the other trig functions in terms of those two. If I tell you the sine, you can get cosecant. If I tell you the cosine, you can get secant. And if I've told you both of those, sine and cosine, you can get the tangent. So if you know the sine and the cosine of an angle, you can get the remaining trig functions using the reciprocal identities and the ratio identities. So kind of our introduction to this idea of algebraic relationships between our trig functions.